Okay, this continues section 3.1. What I'd like you to do now is I would like you to try to make a linear model based upon the equation, the linear equation in two variables of y is equal to 2 minus x. You saw me do it in the last one, so turn off the video now and give it a try on your own. And then turn it back on and we'll do it together, or you can see how I did it. So I'm going to start here and do the problem. So y is going to be equal to 2 minus whatever my x value is. Remember that the first one we always want to do is the y-intercept. So when x is equal to 0, we get the y-intercept, which is 2. So I'm going to put in when x is 0, I get 2 out. And then I'm going to do it again. So y equals 2 minus whatever x is. I'm going to put in a negative value. Let's put in negative 3. So that gives us 2 plus 3, which is 5. So when x is equal to a negative 3, my y is equal to 5. Let's do it one more time. Y is equal to 2 minus, let's do something positive. Let's do positive 3. So that gives me 2 minus 3, which is a negative 1. So when x is equal to positive 3, y is equal to negative 1. Now we have a 3 ordered pairs that we can plot, and then we can draw a linear model for that, which means that we're drawing a straight line. So 0, 2, plot that. The ordered pair here, because we always want to put the ordered pair on the points. Then negative 3 and negative 5, or no, positive 5, negative 3 and positive 5. So right there, and label it as well. And then x equals 3 and y equals negative 1. There we go again. So we label that one. And same as I told you before, I don't have a very great way of making a straight line, so make sure you're using a ruler and draw a straight line through these points, just as perfect as you possibly can. And that gives us our linear model. So rule of fours, the equation, that describes it. The set of ordered pairs, that describes some of the solution set, but not all of it, but it certainly gives us an idea. The line, which gives us all of the solution set, and then we could also describe it in words. This one says that I'm going to start at 2, and I'm going to take the value of the independent away to get the value of the dependent. So something like this may be like our car example that we've talked about in class and possibly in the notes. I can't remember if we did in our lectures or not, but we start at a 2 and then we reduce that by some increment of x every time. So that would be this example. Now I want to, just because I have a little extra time here, I want to go ahead and take a look at something that's not in the notes at all. And so what I want to do is I want to just say another example in here. And I have this equation, y equals 2 minus x. And one of the things that I might ask is a certain ordered pair a solution? And maybe the ordered pair I want to know about is 3, negative 1. Is that a solution? So the way I would go about that is I would use substitution. This is my x value, this is my y value. So my y value is a negative 1. And what I'm questioning is the truth of this. Is it really equal? And then 2 minus, and whatever my x value is, 3. And that says negative 1 equals a negative 1. And that is indeed a solution because it satisfies the linear equation. And so now we know it is a solution. So that's just a little aside there. Okay, the next one you're going to do on your own again, and then we'll come back and we'll do it just like we've